Good morning, everybody. Wow, it's really like a classroom. First of all, I want to thank the Sirona US team for setting up this nice event here, and to invite me to give you some, let's say, detailed information about our new software, what's behind, what we've done in the background, what we are doing in Bensheim. And since I saw that there are not many people are from outside of the country, I want to give you a short impression on where Sirona is located in Germany. So that red spot there in the middle of Europe, this is Bensheim. Bensheim is a small village, like 20,000 people living there. Am I right? 40? Oh, some more. I live in a bigger city, so I can really judge this. If you go a little bit closer, Germany, so we're right in the middle between Frankfurt, Mannheim, Stuttgart. In the south we have Munich. And if we step again a little bit closer, this is one of our buildings. This is our center of innovation. This is where all our engineers are sitting together. So we built this building and put all our engineers in there, not only CAD/CAM, also from our treatment centers, our instruments, and of course our X-ray engineers. So they all work close together in order to gain synergies out of their ideas and all that stuff. And the second and the third floor is all CAD/CAM. So we occupied most of the building with hardware and software engineers, of course, camera and all that stuff, all developed in this building. There are some more buildings, production, management and all this stuff, but this is, I think, the most important building that we have because there are sitting all our engineers. So when we talk about inLab 15, I have to say we started this project already two and a half years ago. What did we do there? First, we did a usability study. So we invited you, not you directly, but we invited lab technicians into a market research studio. Have you ever been in such a studio? There's a big table with cameras all over, and they have a one-way mirror on the one side. So you have a mirror when you're inside that room, and you sit, and we sat on the other side and could watch these people. They were interviewed, and they were playing around with the software. That time was 4.2. So we did a close look on what they are struggling with, what they are looking for, what they like, what they don't like, what they are telling about of our competitors. Second, of course, we talk to our KOLs, to our key opinion leader, to our beta testers. We do it on a real regular basis, usually once a day. We do that. So we get all this feedback, we collect it, and try to get the best out of it. Then, of course, we talk to our sales reps. They give us also very important input when they talk to their customers, when they talk to prospects. So this is also a resource for us for information. Then, of course, we always take a close look on what are our competitors doing. What is good in this software, what is not so good, what people like about that, what they don't like. And of course, we do some benchmark testing. So what we are doing, we're going into labs that have inLab software and maybe have 3Shape and Exapad software, and we do cases with them. And we note down number of clicks, time for scanning, time for designing, and all that stuff in order to find out where we maybe waste time in our process or where others waste time and have many, many clicks. So what have we found when we do that? First of all, we found we need better workflows, because in dental labs, the workflow is definitely different than what a dentist is doing. So we want to change that workflow with inLab 15.0. Second, we need more performance in the software. We have some calculation times that are really, really long. Sometimes we waste time, so we need more performance. Of course, we need better proposals. That's what we need. Proposals for single tooth restorations are already good, but if the case gets bigger and you're doing a lot of big cases, we sometimes see problems with these proposals. So we need better proposals. Then, I can't read that. Oh yeah, we need more openness. We want to give you the chance to import STL files, to export STL files into other softwares, from other softwares, in order to get your work done. And of course, we need more indications, more lab indications. Norbert already said it, we're talking about screw-retained restorations in the future, something like that. And a very important thing, we need a new color for our software. And I tell you why. This guy, we launched 2013 already. The other guy, just last year. And if you look to that, find the error. The color doesn't fit to our hardware. So, this is what we call at Sirona 50 Shades of Gray now. So, this fits much better to our hardware products. Okay, when we talk about new workflows, more usability, what have we done in 15.0? We did new side panels. First of all, do you know how many clicks you need in order to display your opposing? 3, 4? With 15.0, you just need 1 click, because 15.0 is able to have more side panels open. Not only one, you can open up as many side panels as the software has, and they stay open. So once you want to display your opposing, you just click on that, and the opposing is there. If you want to get it away, just click on it, and it goes away. So easy, saving clicks. Next point, auto trim. The software now automatically trims the die. So when you step from the scan to the model and forward to the margin, this software automatically trims the die, as you can see here on the saw cuts. So you can just click through every die and check if the trimming is okay. If not, you can reset it and you can trim manually if you want. But in most cases, that'll work. So it's just checking what the software does. It's not working on it, it's just checking what the software does for you in the future. And a very important thing, we have auto margin now. So you don't have to enter the margin anymore. The software proposes the margin. And you're not working on it, you're just checking it. You just check the margin if it's correct or not. Of course, you can correct it if it's not where it is. And you cannot see at the moment directly, but when you look at the software, the margin line is now very, very thin. It's not that thick tube that we have now. It's really, really thin, and you can really judge where the margin is now. And the green line, this is the line where your spacer starts in the future. You can also adjust that. So if you want to have more friction on the die, you can simply redraw this line, bring it up a little more, and the crown follows the preparation until that line, and then the spacer opens up. So if you have like shoulder or chamfer preparations, you definitely want to have more friction on the walls of the preparation, so you can adjust where the spacer starts in the future. Mouseover Tools. So what we do today, I have brought a little video with it. You don't have to double click anymore the tools you want to work on. You simply take your tool and you move over the tools, and it's automatically active and you can work on it. When I've shown that video the first time, somebody asked me, how do I get that yellow glow around the cursor in the software? This is just in the video. You will never find it in the software. Okay, again, saving clicks, streamlining the workflow, make the process faster. That's what we're looking at. Group function. You know that we have a group function in the side panel now. In the future, this will be Windows shortcuts, like Shift and Control click. You can select the T's you want to work on. And what I'm doing here, I'm showing how to reduce the whole bridge with just one click. So I selected all the elements, clicked on the Reduce tool, reduced it, and the software automatically reduces all elements of your bridge. Not double-clicking, reduce, next to double-clicking, reduce. So you have a really, really fast process here when you want to reduce the whole bridge or even parts of that bridge. Configurable graphic user interface. What does it mean? These are all the materials that we have in the software. How many materials are you using from this list? 2? 3? Somebody uses all the materials? Okay, just for me. This means yes, this means no, this means I don't know. Okay? So, you can decide now, if you're only working with Sorona or Vita materials, that the software only shows you these materials. You can also decide, I don't have all the block sizes or all the disk sizes in my lab. I don't want to see them when I go through that list and I want to start the milling process. I only want to see the materials and the block sizes I use. So that shortens the selection, makes the process faster. So you can, in the configuration, you can then decide, okay, just show me Vita materials and get rid of all the other materials. I don't use them, I don't need them in the software. Parameter profiles. A lot of people were looking for that. So what you can do, also in the configuration, you can set your profiles for a certain material, for a certain doctor. There are doctors out there that want to have real tight restorations, real tight crowns, and others, they want to have it a bit loose. And you always have to go to the parameters, move the slider around. This is gone. Set a profile in the configuration, and simply click on that when you do the design. And you can have as many profiles as you like. If you have 20 doctors, you can set up 20 profiles. If you use 20 materials, you can set up 20 material profiles. And a very nice thing, I think a lot of people were asking this also, we have now a divided spacer. That means you have a spacer for the radial, and you have a spacer for the occlusion, and you can set them different if you want. So also something that labs were looking for a very, very long time. More performance. This is really hard to show what that means. And it's really hard to program more performance, because performance is a very individual thing. Some think, okay, I like the long calculation because I need to go for a coffee, come back. Huh? This is over. No coffee anymore, just water in a bottle next to your place. Background calculation, what does it mean? This is a screen you probably know. This is the scan tab. But take a look at the image catalogs. You can see these little round work indicators there. And in the software, if it would be a video, they will circle. That means during the scanning, the software calculates in the background already the model. So that model calculation phase, like 2 minutes after you scanned, where you get your coffee and come back, over, sorry. Yeah. So whenever you click the next image catalog, the software automatically starts calculating the captured images. And if you do a regular scan like preparation, opposing, and then the buckle registration, once you step forward into the milling phase, into the model phase, usually preparation and opposing is already calculated. So only the small buckle image needs to be calculated and your model is there. So a very good time-saving program here now. So at least I would guess it saves 50% of all, maybe more, in calculation times. By talking about the scanner, I want to point out some new scan features that we added to that software. I don't know if you know that. Well, this was new to me for 2 years ago. Triple trace. It's very common here in the US, I heard, from our beta testers, from our key opinion leaders. You see, I hear what they're saying. And we designed a scan process for it. So we have a special holder that you can put into the scanner, and the scanner automatically scans both sides of that triple tray, and you don't need a buckle registration for that, though, because it's already in the impression tray. So there's a special workflow if you want to scan directly from the impression in the future for triple trays. Another thing, you can capture lines that you have marked on your model, maybe for partial dentures. So they get captured in the software, and you can display them whenever you like and can work with them. Can draw the lines on or whatever. And there's something, again, in the background. Today, when you step forward, there's a message coming up that we delete the images when you step forward into the design process. And if you want to keep the images, you have to export that file and save it somewhere. This is not a nice process, somehow a little bit cumbersome. So what we are doing now, we're still separating the images from the restoration file in order to keep the restoration file as small as we can, but we don't delete the images anymore. We save them, but we delete them from the RAM so that the complete RAM can be used for the designing, but we don't delete them. So if you want to go back into the scan phase, you're now able to do that, and you can rescan if you want, without taking care of that you have to export that case to some place, then re-import and rescan and all that stuff. So just simply go back to the scan phase and rescan if you want. Now, a very important thing, better proposals. We're looking for that. And I really love what we have there. But first, let me a little bit explain what we're having today. Biogeneric. Do you know what biogeneric is? What stands behind it? Again? Okay, I'm going to tell you. Biogeneric is focused on the occlusal features. So what was done? There were like 4,000 to 5,000 teeth scanned for that algorithm. And what we're doing now, if we have the scan, we're analyzing the occlusion, and within these 4,000 to 5,000 teeth, we find a tooth that fits best to the rest of the scan. But this has a small limitation. It's only focused on the occlusal surface and down to the equator. From the equator down, we're simply guessing. It's just magic. Whenever I ask my engineers, what are you doing there? They always tell me, magic. So whenever I don't know what I'm talking about, I say it's magic. Okay, and another point is that this biogeneric only looks to the adjacent teeth, not to the second adjacent and so on. It only looks to the real adjacent teeth, and if they are not there, the software calculates, let's say, a standard tooth in there. And the problem is, you as lab technicians, you always deal with big cases where there are a lot of preparations, a lot of teeth smithing, so there might be no adjacent teeth, and sometimes we have seen things like that. And it took us some time to get a good design on that. In order to avoid that, we sat down and we said, okay, we need to improve that a little bit. And we find a guy that helped us, and now we have a more global approach to that. And thanks to Johannes, I'm not sure if he's already here, he created a very nice name for it. We call it JOBS. What does JOBS mean? It means jaw-orientated biogeneric setting. So it's not focused on the single tooth anymore, it's focused on the complete jaw. For this model now, there's not only teeth scanned, we scanned the complete jaws. So behind that model are like 500 to 600 complete uppers and lowers scanned, and this is how we start calculating now our proposals. So that means it's a global approach. The whole scanned model is now taken into consideration for the proposal. I think with the X5 scanner, it's not a problem. We always have a full model there. So when you have doctors sending you cases, tell them, scan a little bit more. Not only 3 T's. Give me half arch. It's better. And we're not focusing on the occlusion only anymore. We also focus on the setting, on the angulation, on the rotation of the T's. So we propose a setup, not T's anymore. And there are 2 new things in there. First, we're not only offering biogeneric occlusion, we're also offering tooth libraries in the future. In 15.0, we will have 3 at the moment. They are from Vita, so all the Vita tooth libraries are in there. We have Candulor and Merz for the first step. And of course, in the future, we will add more and more into that. And I know there is a question. I can see it in your eyes. Can I scan my own tooth database? That will come in the future as well. So you can create your own good-looking teeth, import it into the software, and work with them. Positioning. There's a new step before the software now calculates that step. It's called the positioning step. So it's a pre-positioning, and you can see the restorations are not calculated to the margin, so you can freely move around them. You can scale them before the calculation actually starts. Of course, you cannot move only one tooth. You can move a bunch of teeth if you want. So you simply click on Shift, click, Shift, click, and you activate the teeth you want to move around. And thanks to our beta testers, they send me some cases over which already worked really nice. I brought some pictures here from Frankie Acosta. I think a lot of people of you know him. This is a Connect case. And Jay, thank you for that. Another case from Jay, sending me also already really good-looking things. More indications. Norbert said it already. We look for screw retain stuff. And we have different options there. Norbert mentioned the company Anti-Trading. They are selling abutments for implant cases. And we have their abutments and the titanium bases in the software, so you can select them and you can design a restoration on that, screw retained. And the good thing, if you do that on these abutments, you can mill them on the MCX5, because this is not milling the implant connection directly. This is just a simple geometry of a conical tie base, and drilling the screw hole into that restoration will also be possible with 15.0. And there's another company called Medentika. We have the abutments from Medentika also integrated in the software, so you can choose either Anti-Trading or Medentika to do these kind of restorations. Of course, you can do direct screwed restorations with the implant connection in it, as you can see here. These cases will usually be done out of titanium or non-precious in a centralized production. This is not possible with the MCX5 because you have to be very, very precise with the implant connections there. And another feature that we have integrated, we can do so-called Brettau style bridges now. So you have a design element which is called gingiva. So you can design teeth and gingiva separately in the future. So there's a lot of new things in that implant business coming with that new software. And to scan this, we developed a new scan body. It's a single piece scan body that you screw into the implant analog, and we have a new scan workflow there that enables you to scan each position after the other. So you don't have to screw in all 6 of these scan bodies and scan them. You can use just one single scan body and screw it from one position to the other and let the scanner take the position of that scan body, because these scan bodies will slightly a bit more expensive than the ones that we have today, because they have to be very, very precise and all that stuff. So, and I don't know how many implant systems you have in your lab, 4, 5, 6, depending how many doctors you have maybe, so you don't want to have plenty of these scan bodies in the future. Just one per implant system would be sufficient. They are looking like this, and you can screw them into the lab analog. Another thing, before we do the restoration, surgical guides. We have already a surgical guide feature in the software. It's called CeraGuide, but this is not really CAD/CAM. It's just milling out that piece where the hole is in, and you put it into that plastic stuff. In the future, that will be a little bit different. Still, you have to do the X-ray, or the dentist has to do the X-ray. You can design the crown, and then you can match the crown and the X-ray together, do the implant planning, and from that implant planning you get back a file where all the information about the implant is in, and once you import that into the inLab software, we have a new design process to design these surgical guides now on the software, and they can be milled either on the MCXL or, of course, on the MCX5. On the MCXL, we have the 85 by 40 millimeter block, and you can have one hole in there because we only have a 4-axis machine there. If you're using the MCX5, of course, you can do a roundhouse surgical guide with multiple holes in there because of the capability of 5-axis. Virtual seating, another very nice feature that we have. You maybe know that from the past when we had that quadrant feature, when you were doing, I don't know, 4 or 5 inlays or crowns. You did the first crown, then you virtually seated this crown, and then you designed the next one. This feature we have integrated into the software now as well. And I think it's a little bit more. It's now a real multi-layer. I would call it a real multi-layer. It's not limited to 2 layers. You can have as many layers if you like. And what I did here, I did design an abutment. I virtually seated it, and I designed a coping and a crown, a multi-layer crown with a coping on that titanium abutment. So this is just to give you an impression on what could be possible with that virtual seating in the future. I got some very nice feedback already from some German beta testers when I told them, hey, we have virtual seating. They had like question marks in their faces. And they have, what is virtual seating? Nobody knows it. And I said, do you remember the old quadrant stuff? And they said, yeah, now I know what you mean. And they said, oh, do we really need that? And I said, okay, play a little bit around with that and find out. And after 2 days, one called me and said, hey, that's so nice. I did a bridge and blah, 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 and put Emacs on that. And they really love it. And I bet you will love that feature too in the future. More openness. When we talk about that, we are already kind of open in our software. You can export STL files from our software already. So what do we see here? This is the, let's say, the Sirona workflow with software and hardware from us, Infinident as a centralized production if you want. But there are a lot of other systems out there where you maybe want to have files from, at least from the intraoral scanners like iTero, like Trios, and all that scanners, and you'll be able to do that in the future. So we're not having only an STL export in the software, we also have an STL import into that software. So you can import the model, you can design on it, and afterwards you can either decide, do I mill it on my own machine, or do I give it away somewhere? So that software will be completely open with the new interface. And of course, what's coming back, that you can directly export a DI case from the portal into STL and design the restoration in some other design software if you want. STL model import. So this is again the scan phase, and in the side panel on the right, you can either decide I want to scan myself or I want to import a case, and then you click on the image catalog and import that case into the software. It's just a regular import mode that you know. So you import the lower STL into the image catalog of the lower, then you change to the upper, and so on. And for the iTero import, we have a special import created. It's not only the model that you import, you also import the patient data and the margins for that. So this is especially done for iTero cases. I know iTero is a very strong company here in the US. There are many, many scanners out, and you may be looking forward to design cases for iTero dentists. We've also created some new Connect features. Of course, the Connect portal on your side will be gray in the future, not blue, of course. On the dentist side, it stays blue. On our side, it's gray. And more important, we have a chat functionality in there, so you can directly contact your doctor on that particular case, asking him questions, and you can also send files back and forth. So you can design, you can do a screenshot, send it to the doctor. Do you like what I did? Can we start milling? And the doctor gets that right away. And if you and the doctor have Skype on the PC or on the AC unit, you can directly start Skype in that chat as well. So you can chat with your doctor not only on a written base, you can directly talk to him. And I know that some lab technicians use Skype in order to guide the doctor during the scanning. I don't know who it was, but I think it was Frankie. There was a doctor calling him, can you come over to help me with the scan? I said, oh no, I don't have time, but I can remote access and Skype with you. And this is how he did it then, guiding the doctor through the scan. So stay at your chair, have a coffee, and guide the doctor through the scanning. A feature that's not particularly related to our software, but it's part of the CAD software and of course part of the CAM software. We call it Extrafine grinding now in the future. We have developed new instruments, a 0.6 grinding instrument that can be used either on the MCXL or on the MCX5. And you can see we get much nicer looking occlusions if we use that Extrafine grinding instrument. And with the MCXL also the margins get re-milled with that Extrafine instrument. So we're getting out really nice looking Emax crowns in the future, so you can design really nice looking fissures, occlusions, and you get the result out of the machine. In the CAM software, we have also improved our import. We are not having only an STL import, we also have an XML import in the future. So all the additional information about a case you can now import into the CAM software by using that XML format. And especially for 3Shape, we have a special format, the OX format from 3Shape, or if you're using Exocad, the construction file information can also be imported into the CAM software, so you get all the information maybe about the screw hole and all that stuff, and you can mill this in our software. Okay, so this was just a rough overview of what we're doing in our software. I don't want to tell too much because there are a lot of breakout sessions that go absolutely into detail into that new software. Hope you enjoyed my lecture. Nice being here. Hopefully we can talk to each other whenever you have questions, whenever you have wishes for me to do. I will definitely take them back to Bensheim, and maybe in 2 years we're getting them again. Thank you very much.